Hello, welcome back to another episode of the Real Hacker Hours podcast. Today we're going to continue the database exploitation and reverse engineering project. Right now, I've begun looking at a new database implementation called DragonflyDB right here. I figured out how to interface with it a little bit. Here we can retrieve a value key1. This does look, at least in terms of how we interface with it, to be a bit different than a lot of the other database implementations that we've seen. We interface with it using something called Redis, which looks like to be like a web app API sort of deal. I'm not exactly too sure what Redis is, so I'm going to pause the stream real quick and look up to see if I can actually figure out what Redis is exactly. So it appears roughly, I could be wrong on this, but what Redis appears to be is a system for effectively having like a NoSQL database implementation where you can effectively store and save data. And the API for it, the Redis API, is effectively just an API for interfacing with that. We can see here there's a list of various API calls like set, get, that we can use to interface with it. And over here, actually, where is it? Which terminal do I have the database actually running in? That's Wireshark. I don't want that yet. Okay, over here we can see that we're actually running the Dragonfly database, and it's listening on port 6379. And what we can go ahead and actually do over here with this Redis CLI is actually interface with it. I've already set the value for key 1, which is right here. We just get that. I'm going to just show briefly how to set another key value. Let's set key 2. What value do you want to set it to? Okay, you set that value. Okay, cool. We can set. I just briefly showed how to do that. Now, one thing I'm kind of curious of is, actually, I think I've already done this. Does it actually persist the data in a file somewhere? Let's see. I'm going to briefly look through the API calls that it has. API. Set family list. I think I remember something like save. Okay, there is the save API call that I can make. Let's try that. Save. Okay, we're able to actually save it. Exit. Let's try rerunning this. Okay, you see here saving dump this file. And we can see here data directory is this Hackery database, is Dragonfly build op. Let's take a look in there real quick, see what's in there. What I'm trying to locate right now is there, does it actually persist the data in a file somewhere? And if so, can we access it? And then what is the format of the file? We see here that it saved it to this file right here, which appears to be this one right here. So let's go ahead. Oh wait, no. Why am I viewing that? Hex editor? Not a hex editor, a text editor. So you can see over here in a hex editor is what looks like to be the file. You can see here key 2, the pretender, key 1. Okay, this looks interesting. Okay, we see here there's a string of the pretender, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 characters long, which we see right here, OX0D, which is 13. And then we see here for the key value, it's 4 characters long. And we see it's prefaced with OX04. Excuse me for a second. Okay, I'm back. Okay, so what it looks like it's doing here is it's having the it's having, with a record, it stores the key first, then the value, but before those actual things, it has a single byte value that represents the size of that, either the key or the value, just the length of the string. One thing I'm going to try doing just for the fun of this, let's like up this to like OX1B and see what happens when we try to query it. So we tried to run this. Oh, okay. Pretty sure it isn't. Because looking at here, the error that's popping out, address already in use, can't open port 6379. Okay, yeah. I'm going to, let's change this back. Because it's that planet 6379 is still in use. No. I wonder, is there help? Can we just set the port? Binds on all interfaces. Port. Okay, I'm just going to change what port it is. Let's do 6400. Okay, cool. Let's actually try to connect to it. I'm going to look at the man page real quick to see. Redis doc for more information on the command Redis accepts. I'm just going to go real quick what the command is to change the port Redis CLI connects to. Okay, it looks like that command flag is TACP. Who would have guessed? And it's port 6400. Okay, it looks like we were able to actually get there. Let's try to get this value and see what we get. Get key 2. Key 1. So we see that neither key 1 or key 2 is present in here. And the interesting thing about that is, looking over at the log of when it starts up, it was able to actually start up since we can interface with it. However, we see this error loading file internal error when loading RDB file 8. So it wasn't actually able to load in the file. Probably because this, I'm just going to change it back and try running it again. Let's go ahead and try to get it now. Okay, cool. So changing that value did break something. We have to figure out. Okay. What I'm going to try and do now is figure out how the actual logic for how it opens up or imports a database file like this. So we have the source code here, so it shouldn't be that big of a pain. Actually, it looks like it tells us the exact file we need to go to, rdbload.cc. So let's try going there. Redis, actually. rdbload.cc. Does not appear to be in here. I'm going to do a quick Google search. Is rdbload.cc part of like a standard library that's used in here? rdbload. Actually, rdb. Okay, I think it is. Let's RDB in this repository. Include redis rdb.h. Source redis. rdb.h. Okay, concerning that rdb.h is defined in here. Actually, I'm not too sure either way if rdb is a standard library or if it's actually defined within this project. Either way, that will have, since that's probably where the logic for loading this file into memory is, which I need to know in order to understand if I can pull off some shenanigans with like changing the size values. So let's say if we retrieve key 2, we can actually leak data past it. Since I need to understand if that can be happen, I need to understand the logic for actually loading this, which that's probably in this rdb load.cc, which is why I'm trying to find out where that file actually is. Where it is. RDB flags. Define. Looks like it's just defining a bunch of constants, not actually the what do you call it? RDB functions itself. Serverfamily.cc. First, I'm going to see in config.h. Code. I'm searching for config.h to see if it will simply pull up serverfamily.c. If it will simply pull up the file, but it does not appear that is the case. rdb load.cc. Okay, here's the actual file itself. It is defined in the project. I've stopped being stupid about this. Let's see. Where was the exact issue? 6400 loading RDB produced. Data directory defines data directory. Tries to load the file. Error loading file with. Let's take a look through. Well, let's see. What am I trying to find? I am trying to find the logic for where it loads this file. Probably done in here, but it looks like it's called from serverfamily.cc. And it's done on line 224. So let's take a look there to see where it is. And what I'm guessing what's happening is in serverfamily.cc, it's calling functions from rdb load.cc, and that is where I'll be able to actually find the logic. So let's go to line 224. 224 right here. Oh, this is RDB load. 224. Loading. Serverfamily.load. Okay. It says here on line 251 is where it'll actually produce the error. Okay, we see here is where it gives us the error message that I could not load the file. So the logic for loading it happens in a function call above this. Doubly run all IO threads to update the state for non-shared threads. Loading, switch state, global state name. Watch fiber. Okay, I'm looking through this code and it's not immediately apparent to me where the function call. Actually, it's probably happening within here. Proactor launch fiber. I'm trying to think. Let's try just scrolling through here to see where to be loader. I'm gonna just try something for the fun of it. What I'm gonna try and do is what I think might be happening in here is looking at the records. It looks like at the end of this record, it expects a null byte, and at the end of this other record, it expects an FF and a 0. So I'm kind of curious if what's happening is it's seeing that, oh hey, the size of this record is OX3D, so go OX3D bytes past this and expect to see either a null byte or an FF null byte. So I wonder if extending this to the point where, since there's a bunch of null bytes over here, just basically jumping it further down into the null byte section instead of halfway through the middle of this record, if that will change it at all. Error loading file. 1, 2, 3, 4, 5, 6, 7, 8. OX3D. What's okay? 1, 2. I wonder if adding. So looking at the final record, okay, effectively what I'm doing here is I'm seeing if I can sort of guess and just spend a minute trying to cheese this to see if I can't get it to load properly. If this doesn't work in another minute, I'm going to go back to actually trying to properly reverse this. But looking at the size of this, where is this OX? So initially this is OXD and the record ends right here. Since we just added OX30, oh wait, no. For a second I was assuming that these records are OX10 bytes long, but they're not. So OXE. I'm gonna null this out for a second. Looking how the final record appears to be terminated with an OXFF then a 00, I'm gonna try OX, basically where this expects this record to end, putting on that OXFF00. So this is just the size of the record itself, not counting the terminating null byte. So what's OX61 plus OX3D? OX31 plus OX3D plus OX61, which is OX9E, which should be, actually, let's bump it up to OX83. OX83 minus OX95. Okay, I'm just bumping this. So right now I'm bumping this record up so that it should end right there. Let's see if that changes it. It has duplicated key. Okay, looks like we got a different error, which is interesting, but still not able to actually load it. Although one thing that we did get from doing this rdbload.cc line 606, we know that that deals with some of the logic of loading in the actual file, spitting out a bunch of errors. Let's go see where line 606 is. Right here at load item buffers. Okay, cool. So yeah, looks like we're actually going to have to properly reverse this out. So no, we won't just be able to easily cheese this. Okay, now it's actually able to load fine. Load items. Okay, it's been a while since I've read C++ code, so this is probably going to be a bit painful. Shard. Okay, we definitely do know that this function is called, let's try load items buffer. Okay. So it's been 20 minutes, so I'm probably gonna cut it off here. Thank you guys for watching.